Hi everyone, my name is Thomas Kim. Today is November 21st, 2019. This is my third episode about modern C++ type system from C++98 to C++17. In this series of video, modern C++ type system from C++98, I filmed 2 videos up to this point. If you haven't watched my previous videos, please watch them. C++11 introduced move semantic, and the memory model in C++11 was significantly changed to accommodate multithreading in C++ language for the first time in its history. I will discuss C++ memory model in some other future. In this episode, I will discuss move semantic in action. Without further ado, let's get started. For the sake of brevity, in the following discussion, I will drop off template, parameter, list, specifications, and template arguments. Suppose we have a class template as defined below. Class matrix T public, some constructors here, matrix T, constant matrix T, right hand side, dynamically allocates memory for its elements. Copy constructor matrix T operator constant matrix T right hand side dynamically allocates memory for its elements. First, it has to release any existing resource. Now we define an operator matrix T operator plus constant matrix T L left hand side constant matrix T R right hand side matrix T this is temporary matrix L rows L columns T also dynamically allocates memory internally. So we need a constructor like this, matrix T, size T, row, size T, column. I say rows and columns. Dynamically allocates rows by columns elements. Now scroll down. In this configuration, matrix T A 55 B 555 C 5 matrix T D A plus B plus C. In this statement, matrix D should be constructed. It is copy constructed. Fact 1, D is copy constructed. So the copy constructor, we defined this copy constructor at line 16 is called. Defined at line 16 is called. Fact 2, in this expression, A is named, B is named, C is named. So A, B, and C are L values because they are named. To evaluate A plus B, B plus C, this operator is called. Because this is Rvalue reference, to evaluate A plus B, A is Rvalue, B is Rvalue, so left side is Rvalue, right side is Rvalue, so this operator is called. Fact 3, to evaluate A plus B, operator plus defined at line 28 is called. To evaluate A plus B, this operator is called. Inside this operator, temporary matrix T is created. Then L plus B is evaluated and stored in T, then returns T. Sorry, I have to fix L plus R because parameter is L and R. Since the T temporary matrix is named, T is L value in this function block. However, the returned object of type matrix T is unnamed. So the value category of the return value of operator plus is R value. So fact 4, operator as defined in line 30 here returns an R value. In this discussion, I will denote R values of type matrix T by R1, R2, R3, etc. To construct matrix D in this line, step 1, operator plus A plus B is called. The result is R1 A plus B. So in this function, T is dynamically created. T is dynamically created once. Step 2, to evaluate R1, which is equal to A plus B plus C. This operator function is called once again and returns R2, R1 plus C, in which T in this function, this plus operator function is called again. T is dynamically created. Now twice, second time. Step 3. Now D is constructed using copy constructor. In this constructor, dynamic memory allocation for the elements of D is also created. To construct D, a copy constructor is called, in which dynamic memory allocation occurs. So 3 times dynamic memory allocation. Step 4. Each element of R2, the return value of R1 plus C is copied to its corresponding element of D, the final destination. Step 5. The destructor of R2 is called, then the memory for its elements is released. What about the memory for R1? To construct matrix D in C++ 98 style, after evaluating R2, R1 plus C, in step 2, the memory for R1 is destroyed by calling its destructor. Understanding this part is important to understand C++ 11 standard. Once again, after evaluating A plus B, the return value is R1 is destroyed by calling its destructor. In C++ 98 style, in C++ 11 standard, it's not. So to construct matrix D in C++ 98 style, I will copy this line and paste it here. C++98 style program requires 3 times dynamic memory allocation and 2 times destructor calls. One for R1, another for R2, and element by element copy operation. It is very heavy operation. Now I copy from here up to this point and make demarcation. Paste. I introduce move constructor matrix T. This is Rvalue reference, right hand side. The internal of RHS, right hand side, is moved to this instance. No dynamic memory allocation, no element wise copy operation. Now scroll down. Matrix T, Rvalue reference, operator plus matrix T, Rvalue reference, L, constant matrix T, Rvalue reference, R, L, R, in place, addition, return, std, move, L. For this operator, we can define like this. Matrix T, operator, constant matrix T, right hand side, operation, this plus RHS, no memory allocation. I will copy this once again, paste. We of course have to return this. It should be Rvalue reference, return this. So we defined this operator here. Now scroll down. The parameter L is named. Since L is named, it is Rvalue. Its type category is Rvalue reference. Don't get confused Rvalue with Rvalue reference and Rvalue reference. Since L is Rvalue, we have to transfer its ownership using std move. L is Rvalue reference, so we can transfer its ownership. The return value type is Rvalue reference. Return value type category is Rvalue reference. If you get confused with L-value and L-value reference, R-value, R-value reference, everything collapses. So if you are unfamiliar or uncertain about this point, please watch my second episode. I will remove this comment, and also I will remove this comment. What is the type category of the return value of this function? What is the type category of the return value of this function? The type category of this function is matrix T. The type category of this function, the return value, is matrix T Rvalue reference. Rvalue reference. Now, what is the value category of the return value of this function? What is the value category of the return value of this function? The value category of the return value is Rvalue. The value category of the return value is XValue or expiring value. Now I will name this function like this. Rvalue is returned operator plus Lvalue reference, Lvalue reference. And in this case, it returns Rvalue reference operator plus Rvalue reference, Lvalue reference. Because this operator function returns Rvalue reference. So this is RR is for Rvalue reference. It takes Rvalue reference as parameter, Rvalue reference. It takes Lvalue reference as parameter, Lvalue reference. This function returns Rvalue and it takes Lvalue reference. It takes Lvalue reference. Also, in this case, operator plus equal Lvalue reference. In this case, operator plus equal Rvalue reference. Now scroll down. Now let's analyze how matrix D is constructed in C++ 11 standard. we are almost done, so please be patient. Come to think of it, I don't think we need this function. I will delete. Also note that you should not code like this. If you code like this, it is a recursion. So don't do this. This is for conceptual design. Now scroll down to construct D in C++11. Step 1. A is L-value because A is named. B is L-value because B is named. So scroll up. This function L-value reference is called. To evaluate A plus B, this function is called as R1 operator A, B, where R1 is an R value. Please scroll up. This matrix operation internally defines matrix T, which dynamically allocates memory internally and returns this is R value. Okay? As I explained previously. Scroll down. In this step, a temporary matrix T is created and it allocates memory dynamically internally for its elements. Step 2, so R1 plus C should now be evaluated. R1, the return value of operator A and B, is R value, and C is L value because it is named. This function is called. So R2 operator plus R1 C is operated. Step 3, the move constructor of D as defined in line 87 is called as matrix T R2, in which the resource of R2 is moved to D. After moving resource of R2 to D, the constructor invalidates R2. Step 4, matrix D, the final destination is completed and R2 is destroyed by calling its constructor. I move to step 2, alt1 is t created in step 1. So t is still alive. alt2 is r1, which is t created in step 1. So t is still alive. The move constructor of D invalidates R2, that is, T is invalidated when R2 T is destructed, that is, when T is destructed, its internal memory resource is already transferred or moved to D. In this configuration, the memory dynamically allocated in the T in step 1 is effectively moved to D. That is, the resource of T is recycled to D. No element-wise copy operation for the construction of D. Also, note that T was created to evaluate A plus B and survived until D is fully constructed. T is destroyed only after this statement completed. This is the promise or covenant of C++11 standard. Now let's think about this. Matrix T E equals A plus B plus C. The result of A plus C is R value and A is L value. So scroll up, we create another function, matrix T Rvalue reference operator plus constant matrix T Lvalue reference L matrix T Rvalue reference R plus equal L, because matrix is commutative over addition plus. Return std move R. R is recycled. With this, the result of A plus C is R value. Then this operation calls this function. Now let's think about this. Matrix T F equals A plus B plus A plus C. The result of A plus B is R value. The result of A plus C is R value. So matrix T operator plus matrix T, Rvalue reference L, matrix T, Rvalue reference L, R, return std, move L. L is recycled. So we created one function, Lvalue reference, Rvalue reference. This is Lvalue reference. This is Rvalue reference. This is Rvalue reference, Rvalue reference. So 1, 2, 3, 4. Of course, we can merge all these 4 functions into a single function using DECL type auto. C++17 introduced copy elision and named return value optimization. If we use named return value optimization, we don't need move constructor at all. I will talk more about copy elision and return value optimization in some future episodes. Please subscribe to my YouTube channel. Thank you for watching.